The learning objective that I chose is to compare and contrast the four modes of natural selection and to provide a specific example of each. To begin, we must understand what natural selection is. Natural selection is an evolutionary process in which individual organisms with a favorable variation are more suited to thrive in an environment in which their variation can be passed down to their offspring and many other future generations. After many generations pass, this favorable trait will be more prevalent in a population if the environment remains the same. So, to conclude, this trait would increase the fitness of an organism inheriting the trait in a given population. Now, with natural selection, there are four modes which include directional selection, stabilizing selection, disruptive selection, and balancing selection. Directional stabilization favors an extreme phenotype, which ultimately pushes an entire population in one direction. An example of this mode would be rabbits getting faster and faster over time, as slower rabbits would get eaten by predators, leaving the quicker ones to reproduce and create a quicker population overall. Next, we have stabilizing selection. This mode favors phenotypes in the middle of the pack, where it's best to maintain an average phenotype. An example of this mode could include plant height, as smaller plants may not get enough sunlight, and taller plants may suffer wind damage or require more resources. So, plant heights remain constant with very few individuals at risk from being at an extreme. To continue, we have disruptive selection. This mode favors extreme phenotypes in both directions, which leads to a bimodal distribution of traits in a given population. An example of this can include size. An example of this can include size in salmon. Larger, stronger salmon are able to fight for territory and mates, whereas smaller, more nimble salmon are able to avoid competition by sneaking around. This leaves intermediate-sized fish to die off as they're too weak to fight and too slow to avoid other fish. Last but certainly not least, we have balancing selection. This mode does not favor a specific phenotype, and as a result, genetic variation is maintained. An example of this is skin color in humans, in which darker tones can protect you against UV radiation, whereas lighter tones can facilitate vitamin D synthesis. Ultimately, these traits do not affect overall survival, so the variation is maintained. And finally, we can compare and contrast these modes in terms of genetic variation. Both directional and stabilizing selection decrease genetic variation, whereas disruptive increases variation and balancing has no effect. A similar trait of all modes is that they increase a population's fitness. And something else to look at is the mechanism of action, as constant environmental pressure pushes directional stabilization in one direction. On the contrary, disruptive selection has an environment where different resources favor phenotypes on both extremes. And lastly, one shared trait between all four modes is that they are all completely dependent on the environment, which has the ability to determine whether one extreme, two extremes, or an average extreme will be the most favorable. And that is all for me, and here's my works cited section. Thank you so much for your time. Goodbye.